Hi, welcome to the Potter's Roundtable. This is Pottery Shorts, a series of short pottery topics done on the fly. I'm Phil Bernberg, and today's topic is making shrinkage test bars. And by that I mean a bar such as this that you had actually used to measure the shrinkage of the drying shrinkage and the firing shrinkage of a clay body. And so, for example, you might want to, maybe you're developing your own clay body, or you want to compare the shrinkage of several different clay bodies. This is a suggestion as to how to do that. So, and it's important, especially if you are going to be comparing different clay bodies, or you're going to be doing this over a period of time and developing your own clay, is to find a consistent method to do this test. So that's what this is a suggestion. So I've got a small lump of clay here, and the first thing I'm going to do is I'm going to roll it out into a slab. And I typically make the bars that I use, I typically make them about 1/4 inch thick, or roughly the sort of average thickness that my pots are going to be. So especially if I'm testing the clay for use with my own pots, then I want it to sort of simulate what the pots are going to be like. So the first thing I'm going to do is make a slab of clay. And I found it's a lot easier sometimes to start it by hitting the clay before I actually go with the rolling pin. This is also good therapy. And again, with good slab practice, it's important actually when you're making test bars to roll the slab uniformly on all sides and all directions to try to reduce warping or curling later on. So even though I'm doing this in a hurry, I'm trying to use good practices as far as actually making the slab. So I'm turning it and I'm flipping it. Okay, and that's good enough. So now I'm going to lay out the arrangement of the bars on the slab. So the first thing I'll do is I'm going to just start drawing some lines. The dimensions that I like to use for a bar are 5 inches long by 1 inch wide that I'll cut. So I'll lay out a pattern of those and the first thing I'm going to do is I'm just going to mark them on the slab. So this ruler that I'm using actually is 1 inch wide, so it's great. So I can make a series of just inch-wide bars with it. Like that. This will be enough for the demonstration. And then I'll mark one end. And now I'm going to now that I can see that I'm going to go ahead and cut them out here. So now I'm going to lay these about 5 inches long. So I'll say, okay, I'm going to cut the other end off about there. So there are 3 bars that I've laid out. So now I'm going to go ahead and cut them out. Okay, so there are 3 test bars, and now what I need to do is I need to mark the lines on the bars. I'm not going to measure the bars themselves. I'm going to put a very sharply defined line on each bar that I'll be using to measuring the length, because it's too easy to have rough ends or bumps on the end of the bars to change the reading. So I want something that I can read very precisely. So the first thing I'm going to do is I'm going to make sure that the bars are straight, because I've been handling them. And I'm going to make a line, a very light, and I don't want to cut the bar now. I'm just going to use the sharp end of the fettling knife to just make a line down the center just to mark the bar, like that. That's the line that I'll be measuring along. Okay, and now I'll need a metric ruler. So, because what I'm going to do is I'm going to make a 10 centimeter line or a 100 millimeter line down the center of each bar. And the nice thing about this is, if I have it 100 centimeters long and I measure the shrinkage in millimeters, that converts directly to percent. So that if I start off with 100 millimeters and it shrinks to 90 millimeters, I've shrunk 10 millimeters, which is 10%, 10 out of 100. So I can read it directly. And also, if I make it in millimeters, I can pretty much, with a metric ruler, I can read approximately to 1/2 millimeter, which means I can read to 0.5% shrinkage, which is pretty nice, pretty accurate. So I'm gonna roughly, there's my 10 millimeters, let's see here if I got, there's my 10 millimeter line, is right about 10 centimeter line, about there. So I'm gonna, first thing I'm gonna do is I'm just gonna make a mark for one end of the line, like that. And now I'm gonna lay my ruler on it, and I'm gonna make very precisely, I'm gonna mark the other end of the line, like that. And that's all I need. All I need is a little reference line like that, and there are my bars, okay? And then I'll do that on each of the bars. So now I'm gonna, when I measure it, I'll measure from that line to that cross line, and because they're nice, thin, sharp lines, I can measure it very precisely. As I say, I can estimate it to 0.5 millimeter, which is equivalent to 0.5%, which is great. The one final suggestion I would make is make some kind of a, put some kind of a label or an identification right into the bar when you make them. You can always number them later to keep track of them, but one of the things I found is I'll just make, for instance, a series of small indentations like that, or I'll take the point of a pencil or something and make a few dots in it, just any, and so I can end up with, for instance, with, on this bar, I don't know whether you can see, I have 3 little cuts in the bottom of the bar. And that along with the color of the bar and the groups, at least I can tell that this is bar number 3, based on the 3 lines. Okay? Now, once I've made the bars, if let's say I was testing a particular clay body, as soon as I finished making them, that's the start of my timing. What I want to do is I want to time and I want to take measurements of the bars as they dry and shrink over a period of time. So I would call that, this is time 0. So I know that they're starting at 10 centimeters or 100 millimeters long. And then I would let the bars dry slowly, and periodically I'd measure the length again with my metric ruler and record the length. And I'd let that go until finally I get to the point where they've completely dried and they don't appear to be changing anymore in length. So that would tell me that's sort of the progress of the drying. Then I could also bisque fire them and measure them again, and I could high fire them and measure them a 3rd time. And then what I can do is, once I have those results, I can do 2 things with them. I can actually plot up a shrinkage curve that looks something like this. If I make a plot, and this is time, and this could either be clock time, so these could be like Monday, Tuesday, Wednesday, Thursday, Friday, 3 o'clock, 4 o'clock, 1 o'clock, whenever I actually measured it, or it could just be hours since I started, since time 0. So this is time, and this is the length. So the bars, GTH, so the bars start off at 100 millimeters, and then every time I measure them, at a certain time I take a measurement and then I measure them. So what I'll end up doing, if I plot the numbers that I got, I'll end up with something that looks like this. And each one of these points is a measurement. So at a particular time, I measured the length and I plot it, and this is basically showing the progress of the shrinkage. And I'll finally get to a point where, if I'm measuring the drying, the length won't change anymore. So somewhere around here, for instance, it means that's when it was fully dry, and after that, it wasn't shrinking anymore. So this is showing how the drying progressed. I should mention at this point also is, I'm not measuring, people talk about this as the shrinkage rate. This is not the shrinkage rate. I'm not measuring how fast or how slow. I'm just measuring the % shrinkage. Now I could look at this as the shrinkage rate. If I had another clay that dried like that, then I could say, yes, this one had a faster rate than this one because it dried faster. In this case, I'm not worrying about the rate. I'm just worrying about the actual amount. The other thing I can do with it is I can just calculate the actually % shrinkage, which is what you hear about most of the time. And the way I do the % shrinkage, let's say, for instance, I want to know the total % drying shrinkage. At the end of the drying, when it's completely dry, the % shrinkage, I can write it like this. The % shrinkage equals the starting length minus the final length divided by the starting length Now that's going to end up being like a decimal fraction. So in other words, if the starting length is 100 millimeters and the final length is 90, so this is 10, so I've got 10 divided by 100, which would give me, for example, 0.1. And if I multiply this times 100%, I get percent. So 0.1 times 100% is 10%. So as I said, if this was my starting length is 100, and let's say my final at the end of the drying it was 90. So that's 10. So it's 10 divided by the starting length is 100 is 0.1. If I multiply that, 0.1 or 10th of 100% is 10%. So my drying shrinkage is 10%. Okay? I hope this has been useful, and thank you for joining us. Thanks for joining us today. If you enjoyed the presentation, please like it and subscribe to our channel and share it with your friends. This way we get more viewers of our videos. Also, check out our website, www.hfclay.com. We'd really like to thank our patrons for supporting our educational efforts, such as these videos. And if you'd like to consider becoming a patron, go to patreon.com and look for the Potter's Roundtable.